Hello everyone, my name is Benjamin Leener. I'm assistant professor at Polytechnique Montreal, and I'm going to tell you how a small question changed everything in my career. The question was, do you want to file a patent? It was a question raised by my co-supervisor at the time, Julien Coenadat. I was just starting a master's degree at Polytechnique Montreal in 2012, and my research project was to develop an automated segmentation method for spinal cord MRI. For those who don't know, spinal cord is a small structure that is located within the spine that leads to the brain, but it's a curved structure and really small, so when you get good images, even if good image is difficult to delineate from surrounding structures. But after a few months coding in C++ and trying to develop a propagation of a deformable surface, I was able to reach some interesting results on T1 weighted and T2 weighted images. And so in 2013, I submitted my first conference poster that was accepted by SPIE. That was a validation on only 15 healthy subjects. It's not a lot, but it was enough to convince people that it was working. At least it was promising. And so just a few months after that, we wrote our first manuscript, my first manuscript, that was accepted in Neuroimage on the same validation set. And it was at the time that Julian came to my desk and asked me, well, do you want to file a patent for the technology that you just created? And I said, no, why would I do that? I think it's good for releasing an open software. And just like that, we made the decision to create an open source software. And I was not completely aware of the implication of my decision at the time, and I think I made a good choice. It also had some implications that I didn't know that was not so good, as you'll see after. But at the time, it was a great decision, and so we packaged the software into a repository on GitHub. We were actually working on a template. I'll show you that just after. And we wrote in the manuscript. Our program is freely available at that location. Well, it was called the Spinal Cord Toolbox. It was released in May 2014, and the first issues came just after that. And of course, I felt that I had something in my hands that I could not give up. And so I started a PhD with Julian at Neuropoly just to continue working on this project and making sure that it was well released and the research was well done. So SCT, briefly, that's an open source software that contains segmentation tools for spinal cord MRI that completes a template that we created, similar to the MNI template, but for the spinal cord, along with atlases that we can use with an atlas-based analysis protocol with registration framework dedicated to the spinal cord and with tools that are specific to the spinal cord again, motion correction, for example. It's all written in Python, or most of the code is written in Python, and it's released as an open source software under MIT license. So everybody can see the code and use it as they want. But it's more than that. But why did I do that? What did it bring to me? Well, personal benefits. So you may smile if I tell you that most open source software developers work just by altruism. Well, it's true, and it's really true for us researchers in the medical domain. We do it for the benefits of others. So it feels great to actually release a software as an open source software because we know that it benefits others. We have a sense of value because of that. But we also get some recognition from the community because other people can see your name in a publication. You can see your name as a contributor of an open software, and they know your name. So if you want, as a student, to advance your career, it's really great, right? Because every time people are going to use, for example, SCT, they're going to see my name after that. And that's a great recognition that I get. Even if I'm not actively contributing to the Spinal Cord Toolbox right now, I made it happen at the beginning. I feel grateful for that. It's also a lot of self-advertisement. I'll show you just after that. But it also improves the quality of the software, the security of the software, because other people will contribute to the software and will force you, even if they are not coding themselves, they will force you to make sure that the code is well written. because they need to understand it. And so the quality of the software and its customization, it's improved because it's an open software. Of course, it has side effects, and you need to be careful about that. They can have miscommunication and misunderstanding. Um, there is a potential threat to the core business value. And what is that? I'll come to that later. There might be change of responsibilities for the PI and for students, and of course, there are some issues with the funding. Well, change responsibilities. So let's get back to the advantages before going to the side effects. Community recognition. Well, we have a bunch of testimonies in the Spinal Toolbox documentation page, like that says, well, ICT made a breakthrough enabling the quantification of spinal MRI in a modern way. That's amazing to read that, to know that some people are actually using it to make something else, to make their own good. And we've seen that in publications, the number of studies using SCT and citing the manuscript that we released about SCT, and you see over the years that there is an increase in 13, 20, 21. So we know that SCT is being used in real application, in research, and also in clinics, in clinical studies. Self-advertisement. For me, as a researcher, as a student, I got to be the one as a first author on the paper called SCT, and other papers that were presenting specific tools of it. And so every time someone is using SCT, well, I get a citation. And for me as a researcher, even if citation is not everything, well, it feels great and it's self-promotion. So for my career as a researcher, it definitely had an impact because it encouraged me to continue doing research because I knew I could see that there was an impact of my research, at least in the research community. What makes a good open software? How do you make sure that it's going to be used and in a good way? Well, just putting the code somewhere is not enough. You need to have code that is well written, that is well documented, and you need to provide examples. You need to provide good documentation for people to use, tutorial, getting started, web page. You also may want to provide free in-person courses like we have done for quite some time to make sure that people can ask questions about how to use it. But you can also provide feedback about how they would like to use it. And that's extremely important to be open to feedback from the users and the community because they will be the one that dictate how you can improve the software for the long run. And they can also contribute just by saying what they want to do, but also by coding themselves. And we've had a series of contributors to the SCT over the years. We even made larger events like Spinal Cord Gray Matter Segmentation Challenge as a community workshop, just to make sure that we can improve the tools that were presented in the SCT, but other people can also develop their own tools. So that's what makes a good open software. You build a community around this software so that you can improve altogether the software that you just opened. And then we got these amazing testimonies again. Our team used SCT for processing of structural, functional, spinal MRI data sets. We have 18 publications and 10 projects in progress. It's amazing to read that, but also this sentence, the SCT community quickly responds to any question and issue, typically within a day. So that's what it costs to create a good open software. Sometimes it's difficult because you have to provide support. You have to make sure that people are actually using it in the proper way, and if they have difficulties. For example, for installing it on Windows or Mac, you see these two questions that were asked recently. You need to be able to answer these questions and to fix these issues. And that's what makes good open software difficult to maintain and difficult to develop. So open science and open source software is great, but it has side effects. So let's come back to that. As student and PI perspectives, there might be some possible miscommunication and misunderstanding. Many users will use your software, but they're not from the same background, so they may not want the same thing. So sometimes you may have a user that is deep into programming, that wants to change the code, that wants to make his own version of the code, and sometimes you have users that just want to use it, not understanding how it works behind, but just want to use it in their own application. And these two persons will not use the software the same way. So if you want to content everybody, well, you have to write the code that is appropriate for both of these users. It might be tricky. There is a threat to the core business value of the laboratory. Why? Well, what is the core value of a research lab? Well, usually it's to do research. So if you create a software that can provide tools for the researchers, are you still doing research? Or are you doing software development? And that's a valid question, because for SCT, for example, we were doing research how to develop new tools for spinal cord imaging and spinal cord image processing. And it became software that we want to maintain. Well, is the lab doing software development or still doing research? And we have to find a balance between that. And for the students, it might be tricky to see to see exactly what we do, but for the PI as well, it might be difficult to understand where do we go, where do we put in our efforts, what is the best way to run the lab and make our contribution. So it's a threat because you need to understand how it evolves our time. There is a change of responsibilities, and that's really important, because for the students that have developed a new tool, a new research tool, a new research method, now they want to push it into a software. And the PI, for example, could say, well, you have to answer questions when there are issues and bugs and you have to fix things. Well, the students, the research students, they might not want to do that. They might not be able to do that because they are not a software developer. And so that's the tricky part about moving from a research project, a research method, to a software, an open source software. You have a change of responsibilities and someone has to take these. So you may want to hire a bunch of software developers to be able to maintain the software as it is, and leaving the research students and the researcher as researchers. And that's the tricky part, where to find a balance between all that. And of course, there is the problem of funding. How do you fund research, but how do you fund as well operating costs for maintaining the software and for paying for the software developers? That's a tricky question that has multiple answers, but you have to think about that when you actually building this open source software. So, should I have filed for patents? I don't believe so. Patents rights give the holder control over who use software and for what purpose. While the basic idea between distributing software under an open source license is that anyone should be able to view and use the source code and modify it for his or her own purpose. So I try to be open. I try to make sure that people were able to use it. Did I miss an opportunity to make money? Certainly not. I'm here. So I made the right choices. Did I make it easy for others to get published and famous? Well, that's even better if I did. I made sure that people were able to push science forward, and that's a great outcome for me. So take-home messages here. Open science has many benefits, but it requires a lot of effort. So we can talk about open data, which is tricky, but open source software itself, it requires a lot of efforts in terms of documentation, support, building in the community, maintaining the software, etc. Be aware of changes of responsibility. Software development may not be research, and you need to find a balance between that. But most of all, great mentoring leads to great science. I started the project with my co-supervisor and my supervisor at the time, but that's Julian Granada that kept pushing for releasing the software, for making sure that all the answers were correct, all the questions were answers, that organized all these workshops and making sure that people were using it well. So I'm not the only one responsible for that, and so I had a great mentor that led me to great open science. So thank you, and thank you for your attention, and of course, thank you for the funding for helping us in this.